Hello everyone, now we are starting the next part of the chapter media access control. The next point is Ethernet. Both Internet and ATM were designed for wide area networking, but in many applications, a large number of computers are to be connected to each other. For this local area network, was introduced. The most popular LAN is called as the Ethernet. The IEEE 802.3 standard is popularly called as a Ethernet. It is a bus-based broadcast network with the decentralized control. It can operate at 10 Mbps or 100 Mbps or even at above 1 Gbps. Computer on the Ethernet can transmit whenever they want to do so. If two or more machines transmit simultaneously, then their packets collides. Then the transmitting computer just wait for an arbitrary time and retransmit their signal. There are various technologies available in LAN for arcade, but in the most popular one of them is Ethernet. In this section, we are going to discuss about the generations of Ethernet that are traditional Ethernet, bridge Ethernet, fast Ethernet, gigabit Ethernet, switched Ethernet, full duplex Ethernet. So why it is called as Ethernet? The system is called as Ethernet after a luminiferous ether through which the electromagnetic radiation was once thought to propagate. So we'll go by one. First is traditional Ethernet. The traditional Ethernet is the oldest version of the Ethernet created in 1976, which is designed to operate at the maximum data rate of 10 Mbps. The access to this network by a device is through CDMA CD, that is collision detection, that is MAC use CSMS CD, and their media is shared between all hosts connected in the LAN. Second is bridge Ethernet. We can divide a LAN into smaller segments by inserting bridge in between. Bridge affects the Ethernet LAN in the following ways. The first is the bandwidth requirement increases, and second is the collision domain gets started. Third is switched Ethernet. The concept of the bridge LAN can be extended to the switched LAN. An N port switch is used to connect an N stations that are present in given LAN. The bandwidth is shared only between the station and the switch. The collision domain is divided into N domain. The packet handling becomes faster due to the use of layer 2 switches. Next is full duplex Ethernet. The 10 base 5 and 10 base 2 Ethernets have seriously limitations. The communication on this is always half duplex. That means a station can either transmit or receive at a time. It cannot send and receive simultaneously. So full duplex switch Ethernet involves from the switched Ethernet, in which we can station can communicate with the centralized switch in the full duplex mode. Due to the full duplex mode, the capacity of each domain increases from 10 to 20 Mbps. We have to use two links between each station, and the switch, one to send and data and other to receive it. The full duplex switch Ethernet does not need CSMA CD anymore because the carrier sensing need not to be done anymore. Next is fast Ethernet. Fast Ethernet is the protocol designed to work at the higher data rate that can traditional ones. The typically it can support the data rate up to 100 Mbps. The traditional Ethernet can operate only up to 10 Mbps. Hence, the higher data rates for fast Ethernet has been developed. Next is and last is Gigabit Ethernet. The Gigabit Ethernet protocol has been designed in order to operate at the data rate up to 1000 Mbps or 1 Gbps. This is the higher bit rate of all types. The MAC layer was supposed to remain unchanged for all the versions of Ethernet, but it does not remain so. When such a higher data rate is to be supported, the gigabit Ethernet capacity of operating in either half duplex or the full duplex mode. Next is IEEE standards. There are in the institution of electrical and electronics engineering, that is IEEE, has developed the layered architecture and other standards for the LAN. Under their project 802, set up in 1980. The IEEE 802 standards are as follows: 802.1 for architecture management and internetworking, 802.2 logical link control, that is your LLC. Next is 802.3 carrier sense multiple access collision detection, that is CSMA CD. Next is 802.4 for token bus, 802.5 for token ring, 802.6 for metropolitan area network, that are MANs, 802.7 Bandpass Technical Advisory Group, 802.8 Fiber Optic Technical Advisory Group, 802.9 Integrated Data and Voice Network, 802.10 Security Working Group, 802.11 Wireless LAN Working Group, 802.12 Demand Priority Working Group, 802.13 that is not used, 802.14 Cable Modem Working Group, 802.15 Wireless Personal Area Networking Group, and last is 802.16 Broadband Wireless Access Study Group. Next is traditional Ethernet. The traditional Ethernet is the oldest version of the Ethernet created in 1976, which is designed to support the data rate up to 10 Mbps. The access to the network by devices through the CDMA CD, that is Mac uses CDMA CD, and the media is shared between all the hosts connected to the Ethernet. This is figure shows the traditional Ethernet frame format. Uh, the 64-bit, that is 8-byte preamble, allows the receiver to synchronize with the signal, and it is the sequence of zeros and ones. So first is DNSA. Both the source and destination host are identified with 48 bits. That 6-bit address there are indicated by the 6-byte number entered in the destination address, that is DA, and source address, that is SA field of the frame. The packet type field serve as a demultiplexing key. Next is data. Each frame contains 1500 bytes of data. The minimum size of the frame is 46 byte. Of the reason for this is that the frame must be long enough to detect the collision. Each frame includes 32 bits, that is 4 byte checksum. CRC is the last field in the Ethernet frame. The Ethernet is a bit-oriented framing protocol. An Ethernet frame has 14 bytes header, 2 6-byte addresses, and 2 bytes type field. The sending adapter attaches the preamble CRC and the postamable before transmitting. The receiving adapter removes them. Next is start frame delimiter, that is SFD. This is the second field in the Ethernet frame, and it is of 1 byte length. The byte stored at this field is 10101011. This field is the signal of the beginning of the frame. SDF is used to communicate to the station, that is the last chance of synchronization. The last 2-bit 11 alerts the receiver that next field in the frame contains the destination address. Next is frame length. There is the restriction imposed on the minimum and maximum length of the frame of the Ethernet. The minimum length is 512 bits or 64 bytes, and the maximum frame of the length is the 12,144 bit or the 1518 bytes. The format of the minimum length of frame, that is shown in the figure, and the maximum is also shown in the figure. Next point is physical properties of Ethernet. Let us see some physical properties of Ethernet. An Ethernet segment is implemented on a coaxial cable up to 500 meters. A transceiver, which is a small device directly attached to the tap and detect when the lines are idle and drives a signal when the host is transmitting. Tap must be at least 2.5 meter apart. Transceiver also receives incoming signal. It is in turn connected to the Ethernet adapter, which is plugged into the host. All the power of Ethernet is in adapter. Multiple Ethernet segments can be joined together by repeaters. A repeater is the device that forwards the digital signal. Note that no more than 4 repeaters may be positioned between any pair of the host. That is, maximum 4 repeaters we can use. Ethernet has a total reach only 2500 meter, and it is limited to supporting maximum number of 1024 hosts with the 100 base T twisted pair. The common configuration has several point-to-point segments coming out of multi-way repeater called a hub. Multiple 100 Mbps Ethernet segments can also be connected by the hub. Next is physical layer implementation of standard Ethernet. The standard has been defined for different implementation for the baseband, that is digital 10 Mbps Ethernet. So standard common implementations are 10 base 5, 10 base 2, 10 base T and 10 base F. So first is IEEE 802.3 10 Mbps specification, 10 base 5, that is thick Ethernet. The first implementation of traditional Ethernet is called as a 10 base 5 or the thick Ethernet or the thicknet. This was the first Ethernet technology. The name thicknet is due to use of thick coaxial cable. The thicknet uses the bus topology. It is the original 802.3 medium specification and is based directly on the Ethernet. A 50 ohm coaxial cable is used. The data is converted into the Manchester digital signaling. Maximum length of cable segment is 500 meter. We have to use repeater if the length is to be increased further. At the more 4 repeaters are allowed to be used. Hence, the effective length of the medium is 2.5 kilometers because there will be 5 segments of 500 meter each with the 4 repeaters. Next is 10 base 2. This is the second implementation of traditional Ethernet and it is also known as ChipperNet. It uses the comprehensively thin coaxial cable and bus topology. This is at the low cost system 10 base 5, then 10 base 5 and used for the personal computer LANs. The specification as well as uses 50 ohm coaxial cable and the data is converted into the Manchester digital signaling before putting it on the cable. The Ethernet uses a thin cable, support a less number of users and specified for the effective length of 185 meters only. The data rate is the same as the 10 base 5 specification, that is 10 Mbps, and hence it is possible to combine them in the network. Note that 10 base 2 should not be used to connect two segments 10 base 5 cable. Next is 10 base T, that is twisted pair Ethernet. This is the third physical layer implementation of traditional Ethernet. It makes the use of the physical star topology. The twisted pair cable of unshielded type is used instead of coaxial cable as the common medium. The data is converted into Manchester digital signaling before putting it on the cable. The maximum segment length is reduced to only 100 meters. It is much less than the 10 base 5 specification. The advantage of this type is that twisted pair wire is easily available in any building due to the existing telephone connection. As the alternative optical fiber link can be used, then the maximum length become 500 meters. And last is 10 base F or 10 base FL, that is fiber link Ethernet. This is the fourth physical layer implementation of the traditional Ethernet. It makes the use of star topology for connecting stations to the hub. A transceiver is connected to the hub by using two pairs of fiber optic cable. The standards contain the specification as below: 10 base FP, P for passing, 10 base FL, L for link, 10 base FB, B for backbone. All the specification use the optical fiber for each transmission link. The data is converted into the Manchester code and then Manchester signal is converted into the light signal, off for 0 and on for 1. Hence the frequency of Manchester bit stream actually needs to be 20 Mbps on the fiber. Next, thank you.